When we talk about the Earth as a planet where life is possible, factors such as water, atmosphere, and comfortable temperature conditions usually come to mind. However, a key role in shaping these conditions is played by the magnetic field, which protects the atmosphere from the damaging effects of the solar wind and holds vital gases. But there is another equally important component, the magnetic field. This invisible protector surrounds our planet, reflects solar radiation, and holds the atmosphere in place. But what happens if this shield disappears? Dramatic changes await us that could dramatically affect life on Earth. Let's get to the bottom of this question. What is the Earth's magnetic field? The Earth's magnetic field is created by the movement of the liquid outer core, which consists of iron and nickel. Scientists have discovered this relationship by analyzing seismic waves traveling through the Earth's interior, as well as laboratory models that reproduce processes in the core. Modern technologies, such as satellite missions and supercomputer modeling, allow us to study the structure of the core more precisely and understand how it generates magnetic fields. This process, known as geodynamo, generates electric currents, which in turn create a magnetic field. The field is shaped like a dipole with north and south magnetic poles that roughly coincide with the geographic poles. It extends far into space, forming the magnetosphere that protects us from solar wind and cosmic radiation. Interesting fact, since measurements began in 1831, the North Magnetic Pole has moved more than 1,100 kilometers. This demonstrates the dynamic nature of the magnetic field. Why is the magnetic field important? The magnetic field serves several critical functions. Protection from solar wind. The stream of charged particles coming from the sun could destroy the atmosphere were it not for the magnetosphere. Navigation. Many living organisms, including birds and sea turtles, use the magnetic field for orientation. Maintaining the atmosphere. The magnetic field keeps charged particles in Earth's radiation belts, preventing them from being lost to space. Possible reasons for the disappearance of the magnetic field. Earth's magnetic field exists due to the movement of the liquid core. However, there are scenarios in which it could disappear. Core stoppage. If the outer core stops moving, the geodynamo process stops. Global catastrophes. A huge asteroid impact or a massive volcanic eruption could disrupt the movement of the core. Core evolution. Over time, the core can cool and harden, as happened on Mars. Interesting fact, Mars once had a magnetic field but lost it due to the cooling of its core, resulting in the loss of much of its atmosphere. What would happen to the Earth if the field disappeared? The disappearance of the magnetic field would cause many consequences. Loss of atmosphere. The solar wind will begin to destroy the atmosphere, as it did on Mars. This could lead to the loss of water and oxygen, which are essential for life. Increased radiation levels. Without the protection of a magnetic field, the Earth's surface will become vulnerable to cosmic rays and solar radiation. This will cause an increase in cancer. Genetic mutations in living things. Polar auroras all over the planet. Polar lights, caused by the interaction of solar particles with the atmosphere, will be observed not only at the poles but also at lower latitudes. Disruptions in navigation. Many animals that use the magnetic field for orientation will lose the ability to find their way. This will affect the migrations of birds, whales, and other species. Technological problems. Satellites in orbit will be exposed to radiation, resulting in GPS and communications failure. Disruption of power grids. How can humanity prepare? If the magnetic field disappears, humanity will have to adapt. Developing protective technologies. Research is already underway to create magnetic shields for satellites that can be used to protect critical infrastructure. For example, the concepts of magnetic protective domes are being actively discussed in scientific circles. Underground cities. The idea of building underground cities with enhanced radiation protection may become a necessity. Already today, such projects are being developed for future Martian colonies. New materials. Scientists are developing radiation-resistant materials to help protect buildings, transportation, and electronics. Education and awareness. Training programs are being created to prepare the public for life in high radiation environments. This includes developing survival strategies and medical care. Predicting disasters. Systems to monitor changes in the magnetic field may make it possible to predict threats and minimize their effects. Creating artificial magnetic fields. Scientists are developing technologies to protect satellites and equipment. Life underground. Underground shelters may be needed to protect against radiation. Medical advances. Developing new treatments for diseases caused by radiation. Colonization of other planets. Explore the possibility of relocating to other planets with natural protection. Question: will technology be able to get ahead of the consequences of the disappearance of the magnetic field? Historical parallels. 40 to 1,000 years ago, an event occurred that changed the course of history, La Champ. At that time, a temporary weakening of the Earth's magnetic field led to an increase in radiation levels. This not only affected ecosystems, but also coincided with climate change, making life difficult for many species. Animals migrated in search of safer conditions, and some populations were forced to adapt to the new radiation levels. These changes may have affected food chains and ecosystems on a global scale, forcing species to either adapt or die out. Scientists are also looking at the possible impact of La Champ on the behavior of ancient humans, including changes in their migration routes and ways of survival. The event remains an important example of how planetary processes can dramatically alter the course of evolution. At this time, a temporary weakening of the Earth's magnetic field led to an increase in radiation levels. This is not just a scientific curiosity, it may have caused the extinction of entire species. Imagine how animals that were not protected from radiation faced new threats. Studies show that this could have affected ecosystems, forcing species to adapt or go extinct. Scientists are still studying how this event affected evolution and biodiversity. La Champ is not just an ancient disaster, it is a reminder of how vulnerable our planet is and how quickly living conditions can change. Earth has experienced weakening magnetic fields in the past. For example, the La Champ event 40 to 1,000 years ago, a temporary weakening of the field caused radiation levels to rise, possibly affecting the extinction of some species. Geomagnetic reversals. These events have occurred 183 times in the last 83 million years. The magnetic field is not just an invisible shield, but also the basis of life on Earth. Its study remains a priority for scientists, as understanding the processes that enable its existence can help prevent potential threats. Supporting research in this area and developing defense technologies will be an important contribution to ensuring a stable future for our planet. Its extinction would have catastrophic consequences that would require a huge effort on the part of humanity to adapt. However, with the development of technology and knowledge, we have a chance to meet the challenges. Do you think humanity can survive the disappearance of the magnetic field? Share your opinion in the comments.